for the first question is, by using Lewis structure and valence shell electron pair repulsion principle theory, explain the difference in the bond angles between PCl3 and H2O compounds. As you can see, H2O compounds has 4 electron pairs and PCl3 has 4 electron pairs as well. So the answer is H2O and PCl3 both have 4 electron pairs around its central atom. This means the basic electron arrangement is tetrahedral. But as you can see, H2O has lone pair repulsion, while PCl3 has lone pair bonding pair repulsion. So we can say that H2O has lone pair repulsion, while PCl3 has lone pair bonding pair repulsion. Lone pair repulsion is stronger than lone pair bonding pair repulsion. Thus, the lone pair repulsion causes the angle to be smaller. Hence, H2O has smaller bond angle than PCl3. The next question, the cyanide ion is an evidented ligand forming complexes with a metal ion has chemical formula written as OCN- or NCO-. Illustrate possible resonance structures for the cyanide ion. Before we draw the possible resonance structures, we need to know the total of valence electrons. As we all know, oxygen has 6 valence electrons, carbon has 4 valence electrons, and nitrogen has 5 valence electrons. For this negative one, I take this from the chemical formula OCN- or NCO-. The minus means the ion receive an electron. So we need to plus all of this. So 6 plus 4 plus 5 plus 1 equal to 16. So now this is the OCN structure. And NCO structure. Second question, determine the most possible Lewis structure of cyanide ion. Explain your answer. So before we know what is the possible structure, we need to calculate the formal charges in both structures. So what is the formula of formal charge? So the formula charge is valence electrons minus with lone pair electrons plus 1/2 bonding pair electrons. So for oxygen, this is for the OCN- structure. Oxygen has 4 lone pair electrons and 4 bonding pair electrons. So we put it here, 6 minus 4 plus 1/2 times 4 equal to 0. And for carbon has 4 valence electrons. It has 0 lone pair and 8 bonding pair electrons. So we put all the numbers in formula, we get 0. For nitrogen, we get -1. So for the second structure, NCO-, this is the formal charge. Nitrogen has 0 formal charge, carbon has 0 formal charge, and oxygen has -1 formal charge. Back to the question, it asks us to determine the most possible Lewis structure of cyanide ion. So the answer is NCO- is the most possible structure because the -1 formal charge is located on the more electronegative atom. Oxygen is more electronegative than nitrogen. Okay, last question. C. The Lewis structure of 18C2H2 is shown below. As you can see, this carbon has triple bonds. The first question is, predict the type of hybridization of C atom in this molecule. So, the question asks us to predict the type of hybridization of C atom. This C atom. So the answer is C atom has 0 lone pair. As you can see, the C atom has 0 lone pair and has 2 bonding pairs. We're gonna look at this. We're gonna look at this. So C atom has 0 lone pair and 2 bonding pairs, 1 and 2. Thus, the type of hybridization of C atom in this molecule is sp. Next question is, illustrate the hybridization process of the central atom and the overlapping of orbitals, showing all the sigma and pi bonds formed in the 18. Before we draw the overlapping orbitals, we need to know the ground state, excited state of these atoms. So ground state of C, for this ground state we use valence electrons. So for C has 4 valence electrons, right? So we use 1, 2, 3 and 4. 1 sigma bond equal to 1 unpaired electron, and 1 pi bond equal to 1 unpaired electron, but in pure orbital. So we need to memorize this. Okay. For these molecules, we see that it said we have 0 lone pair and 2 bonding pairs. So 2 bonding pairs, we need 2 unpaired electrons. Bonding pairs means 2 sigma bonds. So 2 sigma bonds equal to 2 unpaired electrons. So here we have 1, 2. But for this 2s2, we need to excite it because it has triple bond here. So triple bond means we have 1 sigma bond and 2 pi bond. So 2 pi bond means we need to have another 2 unpaired electrons. So we need to excite this. So we excited this one to this. So excited state of C, we have 4 unpaired electrons. So hybrid state of C is sp and 2p, pure orbital. So this is the pi bonds, this is the sigma bonds. So we need to calculate the ground state of other atoms as well. So here we have ground state of H, hydrogen. So hydrogen has 1 valence electrons. So we have this here, 1s1. So now we can draw the overlapping orbitals. For first step is to draw the overlapping orbitals. We need to draw the sp. Sp is the one we get from this hybridization. Type of hybridization is sp. So we draw the sp first. Sp is this. So this is the sp. This is the sp for 1 carbon. Yeah, for 1 carbon. Since we have 2 carbons, we're gonna draw 2. This one and this one. So, and then we can draw the for the hydrogen. Hydrogen is 1s. S means it's a circle. So we put it 1 here and 1 here. Okay. So this C is equal to this. This C equal to this. H, 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 and H. So, and next we need to write this down. 1s, 1s, sp, 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 and here sp. You also need to draw the electrons, the shared electrons here, here, and here as well. Okay. Next, here we have the sigma bond 1 and 2. Now we need to draw the pi bonds. So pi bonds we need to draw here. We need to draw here. Okay. I'm sorry for the bad drawings. Okay. And another one. Okay. Now we are done with the pi bonds. this equal to 1 pi bond, and this is for the second one. So for the pi bond, we need to throw the electrons okay. This equal to this. This is the pi bond, and this equal to this, another pi bond here. Okay, we also need to write 2p, 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 and 2p. Our overlapping orbitals is done, but we need to recheck. So this is the sp for the carbon atom, and this is the for hydrogen one, and then we have the pi bonds here. Sigma bond is also here with this is the sigma bond, and this is the sigma bond. Okay.